Next topic is K nearest neighbor learning algorithm. So this is the most important algorithm and it is a basic algorithm in an instance based learning method. This algorithm, it assumes all instance, it corresponds to an n-dimensional space to the power, that is k power n. So here I have indicated r. The r here in the notes it is given as k power n. So it is a printing mistake, don't worry for it. It should be a k power n. So why this is a name k nearest neighbor? So here this is a supervised machine learning algorithm. Here it is going to classify the new query based upon the nearest neighbor, and the k here it indicates the distance from the query point. So understand? So K nearest neighbor learning algorithm, it is the most basic algorithm in an instance based learning method. So we know that what is meant by an instance based learning means, so as and when the query occurs, then only the machine will be activated and it is going to refer to the training database and then it is going to perform the classification. So the first method or the first algorithm in an instance based method we are learning is K nearest neighbor learning algorithm. So here the classification, it is based on the K, that is a distance from the query point, and the nearest neighbor, the based upon the nearest neighbor we are going to classify the query point. So here we are going to consider an n-dimensional space, which is the total size of the space, it is considered to be as an k power n, where k is the distance from the query point. So why we need to choose a KNN? So we know that in a machine learning algorithm, the prediction it is made depending upon the past data that is available. The past data, it is nothing but our database. So we know that this is a basic or the basic block diagram of a machine learning model, where we have an input value. It is given to a machine learning model, and based upon the past data that is present, we are going to predict the output. Example, it is already given in the class. So suppose if I take the if I show you and ask you whether it is a cat or a dog, and you are going to say it as a cat. How you are going to say it as a cat? So because in your memory from your childhood, you would be having the image of a cat. The features of a cat you will be knowing. So that is given as an input value. Suppose all these features are saved in an database that is called as a machine learning database inside this machine learning model. The practical example, if I take a machine and compare it with a human being, you will be knowing that that is a features of a cat. The same way, if I compare it with a machine, the features of a cat or the dog, it will be fed to a machine, and whenever a new input value is given to it, it is going to predict the output whether it is a cat or dog. So we know that this is a basic block or the basic model of a machine learning. So now in order to example, if I consider that is a cat or a dog, picture is given to you. So now you have to classify it whether it is a cat or a dog based upon the training data or the past data that is present. So this is an example based on the machine learning model. So here you have a machine learning model. What a machine learning model has, it will be having the database, that is a previous data will be stored in this. The same way here, so if I consider the images of a cat and a dog, it will be present. So suppose if I give a new query that is an image of a cat, now the machine will be able to classify it and predict the output. Yes, it is an image of a cat. Now how it is done? It is done by using a KNN algorithm, that is nothing but a K nearest neighbor algorithm. So KNN, it is purely based on feature similarity. Feature similarity. So based on this, we are going to do the classification. Now what is a KNN algorithm? So we understood what is the need of a KNN algorithm. So the need of a KNN algorithm, it is mainly to predict. It is mainly to classify. So how it is going to classify? It is based upon the nearest neighbor. Now what is a KNN algorithm? The KNN algorithm, it is the simplest supervised machine learning algorithm. Now what is meant by supervised machine learning algorithm? It is nothing but supervised means there will be a labels for classification. This we have already seen in the classification of machine learning. We have 4 types, that is supervised, unsupervised, semi-supervised and reinforced machine learning. So in that I have already explained supervised machine learning is the one which has the labels for its classification. Now based on this, based on the labels that is present, it is going to classify. So Knn stores all available cases and classify the new cases based upon the similarity measure. I told you Knn, it is mainly based on feature similarity. Suppose if my query is, suppose if I am comparing the image of a cat, if I am comparing with its claws, or suppose if I am comparing with the ears, so then it is going to compare the features that is already stored in this database with the feature of the image. So that is a feature similarity. So image of a cat, suppose if I consider the feature to be as a ear of a cat, it is compared with the ear of a cat in this database and correspondingly it is going to give the output. So this is known as a Knn algorithm. So what is a Knn algorithm? Knn algorithm, it is a supervised machine learning algorithm. It is one of the basic algorithm in an instance based learning. It is going to classify the things based upon the nearest neighbor, and k is called as the distance, and the size or the total dimensionality, it is based on k power n, where k is known as a distance and n is the dimensionality space. So example I have taken here is a new query, that is an instance is image of a cat, and it is going to compare it based on the feature similarity in a Knn, and it is going to predict the output as cat or dog. Now this is same as that of your basic machine learning model. Now suppose if I take an example how the classification is done in an Knn. So this is the example I have considered. So here the triangle represents the cat and a circle represents the dog. So here I have plot an axis, that is the length of an ear versus the sharpness of claws. So length of an ear, it is a feature, and the sharpness of a claws, it is also one of the feature. So based on this feature I have plotted a graph of triangle represents a group of a triangle represents a cat, and this group represents the dog. Now suppose I have a new query. I want to know this whether it belongs to a cat or whether it belongs to a dog. Now in a Knn method, so we are going to consider a nearby neighbors depending upon the k value or depending upon the distance. So here I have considered the surrounding circle, I have drawn it. Nearest neighbor to it is, yes, it can be a triangle, yes, it is also a circle, but if I draw a circle and here I can see that it belongs to a dog and I am going to predict it as dog. But what I know actually a triangle, it should belong to a cat, but a machine is classifying it as a dog. Now it is purely based on the distance or the k value. So here I have considered a k value as 1, 2, 3, 4. So nearing 4 neighbors I have chosen, and I have told it as, or I have predicted it as a dog. Let's see the next example. So here I have considered an example, and this is a query point. So here this shape indicates it is a white wine, and this shape it is a red wine, and my query is whether it belongs to a red wine or white wine. The feature I have considered here is a chloride level, and here it is sulfur dioxide level. So now here I am going to draw a nearby points or the nearest neighbors of this query. The nearest neighbor of this query, when I drew a circle, I can find it only 2 I have white wine and 3 points I have red wine. So I am going to classify it as a red wine, but actually we know that what it belongs to an white wine. So these are the example of a Knn. Now how to overcome this? So the main important factor in a Knn algorithm, it is choosing the k factor. So let's see how to choose the k factor. I hope you understand how this is drawn. So simply just draw a nearby points or the nearby neighbors of this triangle and just indicate. So if maximum you have the data points you have as a triangle, you say it as it belongs to a cat. Suppose you have a maximum of circles, then you say it belongs to dog. The same thing I have written here. So two data points I have as a white wine and 3 data points I have as a red wine. And since 3 data points are red wine, so I am going to say it as, since it is maximum, I'll say it as the data point is a red wine, but actually it is a white wine. So the main criteria in KNN, it is choosing the k factor. Now let's see an example how to choose the k factor. So let's take another example. So we know that this is a query point. So I have to classify it whether it belongs to a square or whether it belongs to a triangle. So this is a main example here. So in this I have taken the subpart of it. So just see here, if I consider the k value as 3, then I have to choose a nearby 3 data points. When I choose a nearby 3 data points, I am going to predict it as a square. So when I consider this example, I told this example is a main, from this sub example is considered. So if I take here, you can see here, if the k value is 3, then I have to consider the nearby 3 data points and I am going to predict it as square. So suppose if I consider the k value as 7, means I have to choose 7 neighbors. So I have to choose the 7 neighbors, and if I count it, it is 1, 2, 3, 4, 5, 6 and 7. So which is maximum here quantity. So I have 3. So if I take the complete thing, so I have 3 square and 4 triangle. Now I am going to predict the square as triangle. So observe it. Choosing a k value is very important. If I choose a k value here as 3, then it is a correct prediction that it is a square. But if I choose a k value as 7, then I have predicted it as a triangle. Why? Because in this I have maximum 4 data points as triangle and just the 3 data points as a square. So maximum is triangle. So that's why I have chosen, I have predicted square as a triangle. Now how to choose a k factor, it is very important. So Knn algorithm is based on feature similarity. We all know that. Choosing the right value of a k is a process called parameter tuning, and it is important for better accuracy. So choosing a k value, it is a main important factor. Now k value, it is chosen based upon a formula that is called as a Euclidean distance formula. So Euclidean distance, it is a square root of summation of a difference between the query point, or it is a distance from the query point to the main point. So when I solve the problem, you can understand this formula. Usage of this formula you are going to understand. Just understand. So it is d, it is nothing but a Euclidean distance. So it is xi, ji. Xi and ji are the two instances we have considered here. It is equal to square root of summation r equal to 1 to n value ar of xi minus ar of ji the whole square. So here a, a1, a2, a3, depending upon the r value, it is nothing but the feature vectors, or what are the different features you are considering. So that is an r value. So now ar of I, it is nothing but a query point or the query value minus the original value or the neighboring point data point value. So this is an Euclidean distance. Based on this, we are going to choose the k factor. So what is a k here? K, it is a distance from a query point to your neighboring point, or the k value decides the number of neighbors. So k value, it decides the number of neighbors. So that is about k nearest neighbor algorithm. So which is the most important topic. Now let's see the continuation of this algorithm. See here, in a Knn algorithm, the Knn can be applied to a discrete value or a continuous value. Means my target function in the sense my output. So my output can be here whether it can be a continuous valued or a discrete valued depending upon the application. Suppose if it is a discrete valued, so the function f function, it is equal to k power n is to v. It is the finite set. Means if you are considering a discrete target function, you will be having a certain boundary. Where if you consider a continuous function, then you have a certain shape of a boundary. Fine. So k power n, it is nothing but the complete dimension, where k indicates the distance and power n indicates the dimensionality value. As a whole, k power n, it is nothing but a complete hypothesis space. It indicates the complete hypothesis space. Since it is a discrete value, we have considered v1, v2 up to vs. It is a finite set. Now, if I consider this example, so this is a function f of xq. But if I consider this is my query point, xq is my query point. So if my k value it is equals to 1, then it is going to be positive. So suppose if I consider the k value to be 5, then it is considered to be negative. Why? Because so 5 neighboring points I am going to choose it. 5 neighboring points I am going to choose it. So if it is only one neighboring point I am going to choose based upon the distance. Understand? So how I am going to draw this circle? So based upon the distance calculation. Suppose I have an xq here. So which is near to that? That is considered to be k equal to 1. Now how to calculate which is of a smallest distance? That is based on this formula. Understand? So this query point, if my k value equal to 1, then I must choose the first or the only one nearest neighbor I have to choose. I don't know whether it is positive or negative. So now how I am going to calculate based upon the distance, which is of a smallest distance, I am going to consider that one. So since I have taken here my positive is more near to my xq. So when k equal to 1, f of xq is positive. When k equal to 5, I am going to consider the nearby 5 data points based upon the distance. See here, this positive is much farther when compared to this positive and this positive. So depending upon that distance, only 5 nearest neighbors are being chosen. Now since negative points are more when compared to positive, and I am going to classify it as f of xq is negative when k equal to 5. So in a discrete valued function, you are going to choose a finite set value. So that is an important point in discrete valued target function. Now if it is a continuous valued target function, the shape of the decision surface. So now what is meant by decision surface? The decision surface means when you have a query point, and how you are going to classify it, this complete thing or just k power n value, it is called as a decision surface. So when you have a query point and how we are going to classify that query point, that complete area is called as a decision surface. So if you have a continuous valued target function, then at that time the shape of the decision surface is induced by one nearest neighbor over the entire space. The decision surface is a combination of convex polyhedra surrounding each of the training example. So this is a polyhedra structure. So if you consider as a continuous data point, when you have a query point, the nearby polyhedral structure it is going to form. It is just an imaginary format. It is not a rule that this is a polyhedra and this should be a circle. This should be a circle. It is an imaginary point that has been drawn, and this shape is called as a Bernoulli diagram. So when you have this shape in continuous, it is called as a Bernoulli diagram. Now what is this points indicated? It is a data points, and this is considered to be as a query point. So in a continuous target function, you are going to get a polyhedral structure based upon the distance. Now what is the function of f cap of xq? It is equals to summation of I equal to 1 to k f of xi divided by k. This is a function which is used for an continuous valued target function. Now the formula to calculate an f cap of q, it is equal to arg maximum. It is nothing but an argument maximum, means you are going to choose the maximum of this. So the which is a maximum value in these two, you are going to choose that value. That is the meaning of argument maximum. So here you are going to, first we will see the algorithm. I hope you understood the Knn algorithm. So Knn algorithm, it is a k nearest neighbor algorithm. So how many nearest neighbor you have, that is nothing but k value. So how you are going to choose the k value, that is based upon the Euclidean distance formula. So you are going to calculate the Euclidean, you are going to apply the Euclidean distance, and which is near to the query point. So only those data points are considered. Suppose if I have k equal to 1, so nearest neighbor distance, this distance or this distance, you are going to calculate it, and then you are going to say it as yes, this is near to it, and you are going to consider that distance part. So main factor here is the k value. Now let's see the algorithm or the training algorithm and the classification algorithm in an Knn.